Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Foundation Tier. Question number 7 is on the topic of forces. Professional rugby players wear a tracking device which measures their velocity and acceleration. Figure 9 shows a player wearing a tracking device. The player is tackling another player who is running with the ball. Velocity and acceleration are both vector quantities. What is a vector quantity? A vector quantity is a quantity which has both magnitude and direction. Direction only, no, then a quantity with magnitude only is called a scalar quantity. Which of the following is a vector quantity? Displacement is a vector quantity. Yes, it has both size and direction. Distance, time, and work done are all scalar quantities. Figure 10 shows a velocity time graph for the player running with the ball. So we have velocity in meters per second on the y-axis and time in seconds on the x-axis. Question 7.3, determine the acceleration of the player between 0 and 1.6 seconds. So if you look up the equation for acceleration in the equation sheet, it will say acceleration equals change in velocity divided by time taken, or final velocity minus initial velocity divided by the time taken. So what is the change in velocity between 0 here and 1.6 seconds here? The velocity is increased by 4 meters per second. So the time, so 4 divided by the time is 1.6. So what is 4 divided by 1.6? 4 divided by 1.6 equals pi over 2, which is 2.5 meters per second squared. So let's get rid of the calculator. That's 2.5. So 2.5 meters per second squared. Describe the motion of the player between 3.4 and 3.6 seconds. 3.4 seconds is there and 3.6 seconds is there. Now, because it's a straight line, it's a constant gradient. So it's something's happening at the same time, and because it's going down, the speed is actually going down from 4 to 0. We can call it constant deceleration. The force exerted on the player when she is tackled causes her to accelerate. The force exerted on the player when she is tackled causes her to accelerate. Write down the equation that links acceleration, A, mass M, and resultant force, F. The equation is F equals ma. Again, this equation can be looked up on the equation sheet. The word equation is force equals mass times acceleration. Now they have mentioned resultant force, so you can write resultant force equals mass times acceleration, or force equals mass times acceleration. The player accelerates at 25 meters per second. So that's my acceleration. When a resultant force is 1800 Newton. Calculate the mass M. So F equals ma. Force is 1800 equals mass is M, which you're trying to find out. Acceleration is 25. Rearranging the equation, divide both sides by 25 to get rid of this 25 on this side. So that's 1800 divided by 25 equals the mass, which should be 1800 divided by 25 equals 72. Kilogram. Question 7.7. The tracking device sends data to a computer during the game. Suggest one advantage of the data being sent during the game. Well, it allows you to monitor the performance during the game. So collecting data like this allows you to adjust how the players can behave while they're actually playing. That brings us to the end of question number 7 and the end of the paper as well. Thanks for watching. I hope you found this useful. If you did, always hit the like button and the notification bell and subscribe as well. I will link videos for the next couple of papers at the end of this video. Thanks for watching again.